In a finite element model or FEM model, the elements are attached to very specific points in space called nodes. The nodes generally have 6 degrees of freedom, free translations and free rotations. On account of the mesh, the nodes in a finite element model do not always represent points where different members are joined. Many nodes in a finite element model do not correspond to nodes where members are actually connected. The nodes in the finite element model where several members connect together and or with the reference are known as Jnodes, from joint and node. In order to distinguish Jnodes from nodes, a model of finite elements must first be converted into a model of members. A member is a physically unique entity with no internal connections. It is generally modeled using several beam-type finite elements or one truss-type finite element. By examining the model of members, we can understand which nodes are also Jnodes. If a certain number of members n are joined in a node, just as precisely n others do in a different node, with the same sections and the same mutual orientations, then the connections must be defined once only, as they are the same. In c.s.e terminology, this is an example of different instances or repetitions of a given Jnode. A Jnode can therefore have many different instances. In general, there will be a great deal fewer Jnodes in a generic structure than there were nodes in the original FEM model. A Jnode contains a preliminary information only, without detail, about how the various connections are actually made. A Jnode is defined in a wireframe, that is, in a one-dimensional, not a three-dimensional space. For a single Jnode, there may be many different ways of physically implementing the connections, which may be welded or bolted, or involve plates of various shapes or other components. In effect, there may be any number of different ways of physically building the actual connections for a given Jnode. The set of all the entities and joiners uniquely defining how the connections in the Jnode are physically implemented, and the set of all the computational rules specifying how they are calculated, comprise what in c.s.e is referred to as a Renode, from real node. c.s.e has dedicated views for nodes, Jnodes, and Renodes, namely FEM view, Jnode view, and Renode view. The first two are wireframe, the third is solid.